In this video, we are going to discuss an important concept on partial differentiation, Jacobians. Now, what is Jacobians? Suppose u equals fxy and v equals gxy are two functions of two independent variables x and y, then a determinant dabba u by dabba x, dabba u by dabba y, dabba v by dabba x, dabba v by dabba y, which can also be written as determinant ux uy vx vy, is called the Jacobian of u and v with respect to x and y. There are two ways in which Jacobian can be denoted: J equals dabba uv upon dabba xy, or J uv upon xy. Let us learn more about this. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. If x equals uv and y equals u upon v, we have to prove j dash equals 1. Now for finding j, we will require determinant xu, xv, yu, yv. Now xu will be v, xv will be u, yu will be 1 upon v, and yv will be u into derivative of 1 upon v minus 1 upon v square. So yv will be minus u upon v square. Now from these values, j becomes determinant vu 1 upon v minus u upon v square, which will be minus uv upon v square minus u upon v. Cancelling v, this will be minus 2 u upon v. We name this 1. Next we have to find j dash, which is determinant ux, uy, vx, vy. Therefore, we first have to express these given things as u as a function of xy and v a function of xy. For that, we take product xy, that will be uv into u upon v. Cancelling v, we get xy equals u square, or u as a function of xy, that we write u square equals xy. We name this 2. Similarly, if we divide x by y, this will be uv upon u upon v. Cancelling u, this will be v square. In other words, we get v as a function of xy, that is v square equals x upon y. We name this 3. From u square equals xy, we get 2u dou u by dou x equals y, dou u by dou x equals y upon 2u, and also 2u dou u by dou y equals x. So dou u by dou y equals x upon 2u. Similarly, from v square equals x upon y, 2v dou v by dou x will be 1 upon y. So dou v by dou x will be 1 upon 2vy. Also 2v dou v by dou y will be x into derivative of 1 upon y minus 1 upon y square, which is minus x upon y square. So dou v by dou y will be minus x upon 2vy square. Let us substitute the values in this determinant of j dash. So it will be determinant ux, which is y upon 2u, uy, which is x upon 2u, vx, which is 1 upon 2vy, and vy, which is minus x upon 2vy square. This will be minus xy upon 4uvy square minus x upon 4uvy, which will be minus x upon 4uvy plus x upon 4uvy. So j dash will be minus 2x upon 4uvy minus 1 upon 2uv into x upon y. but x upon y is v square, so z dash will be minus v square upon uv. Cancelling v, z dash will be minus v upon 2u. We name this 2. Now jz dash will be this minus 2u upon v into z dash, which is minus v upon 2u. Cancelling 2u and v, we get jz dash equals 1. Hence proved. If u equals y square upon 2x and v equals x square plus y square upon 2x, we have to find dou uv upon dou xy, that is Jacobian J. So Jacobian J dou uv upon dou xy will be determinant ux uy vx vy. We name this 1. Now u equals y square 2x. So ux will be y square upon 2 into derivative of 1 upon x minus 1 upon x square, which is minus half y square upon x square. Uy will be 1 upon 2x into 2y, which is y upon x. Next, v equals x square plus y square upon 2x, which equals x upon 2 plus y square upon 2x. So vx will be half plus y square upon 2 into derivative of 1 upon x minus 1 upon x square, which is half minus y square upon 2x square, and vy will be 1 upon 2x into 2y, which is y upon x. So this Jacobian J will become determinant ux minus y square upon 2x square uy y upon x vx half minus y square upon 2x and vy y upon x. So j will be minus y cube upon 2x cube minus y upon x into half minus y square upon x square. This will be minus y cube upon 2x cube minus y upon 2x plus y cube upon x cube. Cancelling these two terms, we have Jacobian J equals minus y upon 2x. Next, evaluate Jacobian dou r theta upon dou xy if r equals square root of x square plus y square and theta equals tan inverse y upon x. This given theta implies x is equal to r cos theta and y equals r sin theta, cos x square plus y square will be r square into sin square theta plus cos square theta r square. Therefore we get r equals x square plus y square, this part, and y upon x will be tan theta, so theta will be tan inverse y upon x, which is same as this. So from x equals r cos theta we get x r equals cos theta, x theta equals minus r sin theta, and from this y equals r sin theta we get y r equals sin theta, and y theta will be r cos theta. So from this we will evaluate Jacobian J, which is xr x theta yr y theta, which will be cos theta minus r sin theta r cos theta. This will be r cos square theta plus r sin square theta, which will be r into sin square theta plus cos square theta r into 1 r. Now here we have j equals r, and according to property of Jacobians, jj dash is 1. Therefore rj dash is 1. So j dash, which is determinant rx ry theta x theta y, will be 1 upon r, which is this value j dash 1 upon r. Now we will understand very important thing about Jacobians, which is interconvergence for j and j dash. If x is a function of uv and y another function of uv, then we write j as determinant xu xv yu yv. For writing j dash, we must have u as a function of x, y, and v another function k x comma y, so that we can write j dash as ux uy and vx vy. So the most important thing in Jacobians is we must know how to convert x as a function of uv and another function y as a function of uv into u as a function of xy and another function v as a function of xy. Then only we are able to write j and j dash. Therefore, we will learn how to make these interconversions for j and j dash. Suppose x is equal to uv and y is equal to u upon v. Here x is a function of uv and y is also a function of uv. So from this data we are able to find j, which is determinant dou x by dou u, dou x by dou v, dou y by dou u, and dou y by dou v, which in short we write xu, xv, yu, yv. Now in order to find j dash, which will be dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, which in short is determinant ux, uy, vx, vy. So in order to find ux, uy and vx, vy, we must convert x equals uv and y equals u upon v in terms of u as a function of xy and v as another function k of xy. And this is exactly what we have to learn here. What we do, we divide x by y, that gives u upon v. Cancelling u, we get v square. So here we got v square is equal to x upon y, which is v as a function of x and y. Similarly, if we multiply x and y, we get uv multiplied by u upon v. Cancelling v, we get u square. So here we got u as a function h of x and y. Now by using functions v square equals x upon y and u square equals x y, we can easily find dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y, and find j dash, which we have already seen in one of the solved problems of this video. If u equals xy and v equals x plus y, we have to prove that j dash equals 1. Here j is determinant ux, uy, vx, vy. Since u is a function of x and y and v function of x and y, we can easily find the elements of this determinant, which will be determinant y, x, 1, 1. So we get j equals y minus x. So j is y minus x. J dash will be determinant xu, xv, yu, yv. So in order to find j dash, we have to interconvert u equals xy and v equals x plus y in terms of x as a function of u and v and y another function g of u and v. From the given data we have u equals xy, that gives y equals u upon x. We also have v equals x plus y. Here we will write this y as u upon x. So it will be x plus u upon x. Multiplying throughout by x, we will get a quadratic equation x square minus vx plus u equals 0. This is a quadratic equation in x, which by formula method will be x equals v plus minus under root v square minus 4u upon 2. Also from this given data u equals xy, so x will be u upon y and v equals x plus y, which will be, in place of this x, we will use u upon y. So v will be u upon y plus y. Now multiplying throughout by y, we will get a quadratic equation in y square minus vy plus v equals 0. By formula method, y will be v plus minus under root v square minus 4u upon 2. In the solutions of x and y, we have two values of x and two values of y. But we have to choose those values of x and y which are consistent with this given data. We see that if we take positive sign in equation 1 and negative sign in equation 2, we get x plus y equals v, which is same as value given in the data, and xy equals u, which is same as the value given in the data. So we get from equation 1 x equals v upon 2 plus square root v square minus 4u upon 2, and from equation 2 y equals v upon 2 minus square root v square minus 4u upon 2. Here x is a function of u and v, and y also is a function of u and v. Now we can easily find j dash, whose elements are xu, xv, yu and yv. So we will get j dash after simplification 1 upon y minus x. So j into j dash, which is y minus x, into j dash, which is 1 upon y minus x, which will be 1. Hence j dash equals 1 is proved. X is u cos v, y is u sin v. Here x is a function of u and v, and y is function of u and v. From this data we can find Jacobian j, which will be determinant xu, xv, yu and yv. To find j dash, which will be ux, uy, vx, vy, we have to convert this data in the form u as a function of x and y, and v also another function g of x and y. First, let us find y upon x, that will be sin v upon cos v tan v, that gives v equals tan inverse y upon x. So we got v as a function of x and y. Also x square plus y square will be u square into sin square v plus cos square v, which will be u square, and that gives us u square equals x square plus y square. Here u is a function of x and y. So from u square equals x square plus y square and v equals tan inverse y upon x, we can find j dash. After evaluating the determinants, we will get j as u and j dash as 1 upon u. Therefore j into j dash will be u into 1 upon u, 1. So we can prove j dash equals 1. Now we will discuss functions of three variables. If x equals v square plus w square, y equals w square plus u square, z equals u square plus v square, we have to prove that j dash equals 1. Here x is function of v and w, y is a function of w and u, and z is a function of u and v. So from this we can find j as determinant xu, xv, xw, yu, yv, yw, zu, zv, zw. That will work out 16 uvw. Now for finding j dash, which will be ux, uy, uz, vx, vy, vz, wx, wy, wz, for which we need u as a function of xyz, v as a function of xyz, and w as a function of xyz. We will work out z plus x minus y. That will give us 2v square. X plus y minus z will give us 2w square, and y plus z minus x will give us 2u square. So we have v as a function of xyz, w as a function of xyz, and u as a function of xyz, from which we can find this j dash, which after simplification will give us 1 upon 16 uvw. Therefore, j into j dash will be 16 uvw into 1 upon 16 uvw, which is 1. Hence we can prove j dash equals 1. X equals square root vw, y equals square root wu, and z equals square root uv. This gives us, after squaring, x square equals vw, y square equals wu, and z square equals uv. Now here x is a function of v and w, y is a function of w and u, and z function of u and v. Therefore, we can find j, which will be determinant xu, xv, xw, yu, yv, yw, zu, zv, zw. In order to find j dash, which will be determinant ux, uy, uz, vx, vy, vz, wx, wy, wz. We have to convert these functions in terms of u as a function of xyz, v as a function of xyz, and w as a function of xyz. For that, we write x square y square upon z square, which will be v w square u upon uv. Cancelling uv, we will get w square. So here we got w square equals x square y square upon z square, where w is a function of xy and z, like this. Similarly, we can get y square z square upon x square as u square. So u square will be y square z square upon x square, where u is a function of x, y, and z. And on the same lines, z square x square upon y square will give v square, which is v square equals z square x square upon y square, that is v as a function of x, y, and z. Now we can easily find j dash. In this case, if we carefully evaluate j, it will be 1 upon 4, and j dash will be 4. So product of j dash will be 1 upon 4 into 4, 1. Hence we can prove j dash equals 1. This is how we can make interconversions for j and j dash for functions of 3 variables. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. See you in the next video. Until then, keep watching Number Collage. Thank you.